Good evening to you, or good morning, or good afternoon, wherever it is, whatever it is where you may be. Thank you for joining my session here. Let me share my desktop. All right. 1 second here. Excellent. All right. Thank you for coming to my session today. Today we are going to talk about easier microservice persistence with Micronaut Data. And it's not just microservice persistence, really, it's any application that you're building with Micronaut. You can enhance to make it much easier to persist and interact with the database by using Micronaut Data. So we have a lot to cover today. If you do have any questions, please put them in the chat and we'll take a look at all those at the very end and make sure we get you every answer that you need. This is Oracle's safe harbor statement, and this is me. Again, Todd Sharp. I am a full stack developer. I work as a cloud a developer advocate for cloud and cloud database. I'm based out of Blairsville, Georgia, which is in the southern United States. I've been working with Java, Groovy, Cold Fusion, JavaScript, TypeScript, all kinds of stuff, full stack since 2004. And as I said, I am a developer advocate currently employed by Oracle. So what are we going to look at today? We're going to look at what is Micronaut Data. We're going to take a look at how it does some of the things that it does. And most importantly, I'm going to show you how to use Micronaut Data. So there's very much a lot of code involved in this presentation. We're going to fire up the editor and work through basically building something from scratch. And I think you'll find that the best way to learn this material, especially with something like Micronaut Data, you really have to get hands-on and kind of build with it. So what is Micronaut Data? If you look at the marketing words on the Micronaut website, you'll see something like this. It's a database access toolkit. It uses ahead of time compilation, pre-compute your queries, and then execute them at runtime. So what does that mean, basically? Essentially, it's a way to avoid writing SQL code for boilerplate CRUD operations, and not just CRUD operations, really. I mean, you can get very creative and write just about any persistence or retrieval operation that you need to do with Micronaut Data. You can even get granular down to the SQL level if you want to, but it's a really nice way to get rid of a lot of that boilerplate CRUD, because every application has CRUD, right? Well, most applications have CRUD, and a lot of it is redundant and similar and just gets boring to work with after a while. So if we can get rid of all of that boilerplate and focus on the more challenging aspects, the user experience, these kind of things, I think that makes us better developers. I think if we focus more on the user experience, the user interface, the business rules, the business logic, all those sorts of things, I think that makes for a better application. It's similar to Gorm, if you're familiar with Gorm from Groovy, from Grails actually, but it's all done ahead of time, right? So there's no runtime model that's going to bog down your, eat up all your RAM. There's no query translation. So the performance is going to be excellent with Micronaut Data. It's not anything that you have to, anything that has to be built at runtime. It's all done ahead of time. So the other nice thing about that, well, actually, we'll talk about that in the next slide. So again, there's no reflection, there's no runtime proxies, better performance, better memory consumption. This is the part that I was just about to talk about. It's type safe, right? So since it's all done ahead of time, it has the ability to inspect all of your queries that you define. And if it sees that it can't implement one properly the way you've defined it, boom, compilation fails, no runtime error because of that. So really it's type safe in that matter. And it's available in two flavors, JPA and JDBC. JPA thinking Hibernate, and SQL is the JDBC flavor, right? So how does it work? First, you define an entity, you create a repository, you compile, and then that's it, you're done. In other words, you create this repository interface, you extend one of the built-in classes in Micronaut Data, and all of the necessary queries based on the properties of your entities all those queries will be created at compile time. And at runtime, they're ready to go and can be executed. So I've done a little prep work. I've created an application, and let me kind of walk you through a few of the steps that I've done to get where I am right now. First thing I've done is I've created an application. I've done that with the Micronaut CLI, which is available via SDKman or other ways that you can obtain that. But you don't have to use the CLI. You can use launch.micronaut.io. However it is you get your Micronaut application created, whatever method you're familiar with or comfortable with, use that. In this case, I've used the CLI. The next thing I do is declare a data source. In fact, this is done for you when you create an application that specifies that you're using Micronaut Data, in this case, data JDBC, which is what we'll be using throughout today. I find the JDBC flavor a little more interesting because it's kind of different, right? I mean, at least in my experience, I've worked with JPA, I've worked with Hibernate, I've worked with Gorm, many different implementations of Hibernate over the years, and kind of familiar with how that works. But JDBC is something a little different. It's and actually, there's a little better performance when it comes to JDBC because you're one layer of abstraction, I guess you could say, closer to the database. You don't have that, that second level cache or any of that to deal with. So create a data source. Your Application.java class, open that up, add a type hint, and this is going to be specific to the actual database that you're working with. In this case, we're going to first look at using H2 in-memory database because it's nice, it's easy, and it just works out of the box. You don't have to do any configuration or anything like that, right? And in this case, I'm going to also use create a ground native image out of the application. So I modify the native image properties just to add a few things here. The name of the application, the main class, and so on and so forth, and the driver. So let's get into the code. Let's take a look at creating a domain model. And this is really easy. It's not going to be anything that probably is too crazy or looks too different than anything you've really done before, but it's necessary. So let's do that really quickly. And in this case, we'll call it a book, right? So to work with Micronaut Data, the first thing we need to do is declare a mapped entity. This is so Micronaut Data knows this is an entity that I need to manage and I need to work with. So all to do is add that annotation. The next thing we need to do is we're going to work with a book demo. So, this is kind of something that is straight out of the docs, but it's easy to follow. It's easy to work with. So we'll stick with that. So declare some properties. We'll do an ID, a title. We'll do the amount of pages in the book, and why not the published date, right? So published on. So we've got our properties declared. We do need to annotate the ID property with ID and also tell Micronaut that it's a generated value. Create a constructor here, everything but the ID, and some getters and setters. Right. So again, nothing special, nothing crazy, nothing you have never seen before. A very simple domain model, entity, whatever you want to call it, but necessary to work with going forward. So there we are. Let's talk about repositories. So as I said, the kind of key to working with Micronaut Data is something called a repository. And there are a number of built-in repository interfaces that you can work with to extend depending on the requirements of your application. For example, we have, as you can see here, pageable repository, and this is going to add methods for pagination. As you can see, there's also repositories for async, for RxJava, whatever it is that you need to do, whatever is specific to your requirements, you can pretty much extend it from here. Now, I know what you might be thinking at this point. just being able to extend an interface and get all of these methods out of the box is nice, it's handy, it's helpful. But what about those times you want a little more control and you want to be able to write your own queries? Well, in that case, you can then create your repository as an abstract class, right? So if you implement CRUD repository in this case and create it as an abstract class, you do have the ability to create concrete implementations. You can, just as you see here, just inject the JDBC operations and work with that to prepare and execute your SQL statement. You can also inject, if you're using Juke or Query DSL or Spring JDBC template, whatever you may be using, you can inject those and use those just as well. All right, so demo 2, let's create a repository. And this will be, again, very simple. And we'll create an interface called repository book repository. All right, the only thing we need to do here is annotate it with JDBC repository, since we're using the JDBC flavor of Micronaut Data, and tell it which dialect we are working with, and then just extend CRUD repository, and just tell it the entity and the type of ID. And that's it, we're done. At this point, if we invoke our code completion here, we can see all of the methods that we get out of the box just by implementing this interface, extending this interface, right? We have delete all, we have save, count, find all, exist by ID. All of these are going to be available for us. We don't have to write a single line of code because Micronaut Data knows from our entity what the properties are, and it will be able to create at runtime, at compile time, create all the queries necessary to do the operations that you see here in autocomplete. Really nice, really helpful, really handy. The one thing else I'm going to do here is just create a little file called bootstrap. And this is going to have an event listener inside of it, just to kind of bootstrap out some records. That way, every time the application restarts, we'll have some data to work with for my demos going forward here. Let me just make sure. All right, everything's starting up. So as you can see here, I've got the application running in continuous mode. And as soon as I saved that, everything started, the application restarted, and all of my tables were dropped and recreated, and my bootstrapped values have been inserted into the database. So that's good. We can't really work with those yet because we don't have a controller, but we'll get to that next. So out of the box, as I showed you, you have support for count, delete, find all, find by ID, save. The only kind of caveat here, the only exception here is update when it comes to working with data JDBC. And that's because there is no concept of, there's no session concept like there is in JPA, right? There's no dirty checking. So with update, you do have to declare the method and define the, basically you just define the signature of the method, the properties that need to be updated, and it's good to go from there. Check the docs on that. Not really a big deal, but it is something that I feel like you should mention. I should mention. All right, let's look at the controller now. We'll create a controller so we can start working with the application. And actually, let me start up Postman here in the background, so that'll be ready for us when we need it. So we create a controller. We can call it book controller in this case. And we annotate that with controller like we would any other Micronaut controller. And we'll execute that on the IO thread. All right. And within our constructor of our controller, let's inject our repository, which is really easy to do. That way we can use our repository from within our controller. Now I'm going to use the repository directly from the controller here instead of creating a service or anything, just for ease of kind of getting everything done here. but normally I would probably most likely use a service and inject that service instead, or a manager, or whatever you want to call it. So let's add some controller methods. We'll do get books, and then within get books, we're going to return an HTTP response of OK, 200 response. And within that response, we're going to say book repository.find all. So that's going to return all of our books. If we want to just list all of our books, we can do a get to the root, I guess the slash endpoint of slash book, and we'll get all of our books. We can add another get method, and this will allow us to get by ID. So if we just populate that as such, and we'll add a save endpoint. Oops. And within our save endpoint, we will call book repository.save and pass it the book. So because Micronaut is so awesome, it will just take a JSON representation. It will properly serialize that as a book, and then we can pass that book to our repository to save it. One more method we'll add is the delete method endpoint, and we'll receive an ID from that, and we will call book repository.delete by ID. So we have created, as I said, a method, an endpoint to get all of our books, a method to get our books by ID, a method to save a book, which uses the HTTP method post, and a endpoint to delete our books by ID. So at this point, the application should have reloaded and started up, and we can come over to Postman and we can run a few tests here. So if we hit the just the regular endpoint, just the root of the book endpoint, we see that we get a list of all of our books that I scaffolded out in the bootstrap method. So we have 4 books here, and get them all back in JSON format. If we wanted to create a new book, we just pass it a JSON representation. So in this case, title, pages published on. And if we pass that, we get a 201 created back, and we can see that ID of 5, we have a new book created. If we come back to list books and we run it again, we now see that we have 5 books here. Test our get by ID method. So in this case, we'll get a single book by ID, in this case, the brand new book that we just created. And now we can test the delete endpoint to delete by ID. We get no response back, but we get a 204 no content, which means the server processed the request, but it's not returning any content. So there's no reason to return any content with the delete because you've just deleted the item. If we go back to the list method and list them all, we can confirm that now we are back to 4 books. So the delete was successful. Awesome. Now that we've tested all that, let's take a look back at the slides and see where we're going next. All right. So out of the box, we have support for basic CRUD, right? But Micronaut Data also has the ability to support, support for custom queries inside of our repositories. So it gives us the ability to construct queries by using a very specific convention inside of our repository interface, right? It's kind of known as a query by convention. And with the query by convention implementation in Micronaut is based on the concept of dynamic finders in GORM, if you're familiar with GORM again, which itself was influenced by the dynamic finders in Rails, but let's not talk about that. So queries are matched at compile time as opposed to runtime at GORM, like I said earlier. And the pattern that it follows is basically uses these different, what they call stems, to construct and figure out what you're doing and construct the query appropriately. So the first stem is called, I like to use find, but you could use, there's a number of different terms you could use to whatever makes you more comfortable, right? I like find, but you could use query, search, retrieve. There's a number of them. You could check the docs and see all the acceptable versions. So the rest of the query, the rest of the pattern consists of different stems. Some of these stems are optional. So if you wanted to find a projection, like a single property of an entity, you could include that as the second stem. If you wanted an order by, you can optionally include that stem. But it gives you this really, really powerful kind of flexible way to craft your repository queries just by naming the method a certain thing. So it allows us, like I said, to get really creative and construct pretty much any possible query that you can imagine. And going back to my days in Gorm, I mean, sometimes you get these really long, really verbose query names or function names, but it's very easy to see exactly what that query is doing just by reading the name. Everyone has autocomplete in their IDE, so who cares how long the name is, right? But take a look at this query, for example, and we'll kind of talk a little bit what this means and how it translates, right? So find by pages, order by published on. Without ever having written a query like this, you pretty much immediately know exactly what it does, right? Basically, it translates to select all from books, from book where pages equal some variable, and order by published on. And it's going to return a list of books. What if we didn't want the entire book object? What if we just wanted the titles of the books, for example? In that case, we could just, like I said, add that projection, find title by pages, and now we'd get a list of strings back. What about our where clause? Well, currently we're finding all books where pages equals something. The equals is the default operator there, but we can change that up to be, for example, greater than just by adding a suffix. And trust me, there's support for any potential operator that you can imagine. Enlist, less than, whatever you can imagine, contains, all of the suffixes, all the clauses that you would imagine would exist, do exist, and you can do queries like that. You can chain conditions using and or, and you can also, as you see here, change the direction of the sort by adding a suffix direction to the property name that's being sorted. Dynamic finders can also be written to perform other operations. You could do count by, you could do exist by, and you just change that first stem, and you can see here they each return they have a different return type. So exist by is going to return a primitive or wrapper Boolean. Delete by is going to return a void or a number return type. So depending on what you're doing with that query, you're going to get a different response object. So let's write a few custom queries in our application. We'll come back to the book repository here, and we will add a couple custom queries. So like I said, what do you need to do? I mean, whatever you need to do can pretty much be done by using this particular query by convention. So in this case, if we wanted to find pages greater than, we just create a method called a signature in our interface called find pages greater than, find by pages greater than. And it receives one argument, the number of pages we want to find greater than. What about find by title like? Like I said, if you wanted to do a different type of query instead of equals, you can do a like query, and you could pass the title to do that. If you want to do a case insensitive like, you can do find by title I like, I being insensitive. And watch it, because it's easy to put a uppercase L in there and it will not work. I can't tell you how many times I've made that mistake myself. So make sure you do I and then a lowercase L. You can get really creative, as I said, find by pages greater than and pages less than, order by published on descending. Whatever you need to do, you can define it out in this format. Now, it might get a little verbose, it might get a little difficult. And at that point, if you want to reevaluate things and maybe change to an abstract class, maybe take another approach, as I'll show you in just a few minutes here. But you can get as flexible and powerful as you want to with this approach. In this case, we're doing a projection. We're going to return a list of strings instead of a list of books. And we're going to do find title by title I like. So essentially, anything you need to do is possible using this query convention, right? Let's add one more method to our controller here. So in this case, I've added an endpoint that we can use to find by title and then pass that title in as an argument in our URL. And we're going to use that repository method that we just defined, find by title I like, and then pass some % to do kind of a wildcard substring search by that specific substring. So if we come back over here to Postman and we test that out, you can see that I have passed the substring, the word the, THE, and I get back 3 books out of our 4 that all contain the substring the, THE, right? So you can see those all there. All right, so that is how to create custom queries. Let's go back to the slides and talk about, before I move on to the next section, there is an alternative to the find by syntax for repo queries. So you can define very simple finders that use the parameter names, in this case, title, to match properties to query. It's a little less flexible, but it's slightly more readable. So, compromise is less flexible, more readable. It's up to you how you want to define these. If you do pass multiple parameters in this using this method here, it'll result in a logical and. So you cannot if you cannot have a signature that you want to use an or in, you would have to go back to the dynamic finder syntax. But it is an option if you want to keep things simple. It's something that you could do. So these custom queries are awesome. They're powerful, but sometimes you don't need your entire entity back, right? You, especially if you have a very large object graph, if you have relationships, many to one, one to manys, many to manys, you might not want the entire object graph to be serialized and sent back across the wire. So I showed you how to use projections to get like a list of strings, find title by title, but Micronaut Data also supports data transfer objects. So if you want to just grab a couple properties or a subset of properties from an entity, you can do that with DTOs. So let's take a look at how to create a DTO. Really easy, again, like everything else that we're looking at today. We're going to create a class called bookDTO, and we're going to mark it with introspected, and we just create a couple properties here. So let's say we want to get just the title and the amount of pages from our books, right? We didn't want all the other information. We could just create this DTO that gives us just a couple properties back. So if we finish that up with some getters and setters and come over to our book repository, if we wanted to return book DTO instead of books, we use it in our repository as the return type, and now we call that by point again, we should get back just an array of objects with just these 2 properties, right? And pages. So instead of the entire object back, just by clicking a DTO, changing the return type in our repository, we should get just those 2 properties back. So let's make sure we're on the proper method here and by title. So our last time that we ran this, we got all of our properties back, and this time we run it, we just get back the title and the count of pages, right? So very cool, very flexible. Again, easy to do, easy to work with. Take a look back at the slides here.
Hey Todd, sorry for interrupting you, but your connection might be dying.
It's powerful, it's helpful, but there's always going to be a time where you'd prefer to write your own query with raw SQL. Thankfully, that's really easy to do as well, and I'll show you how to do that. In this case, one way to do it is to use the query annotation inside of our repository, right? So you can see here, we have a
Todd,
query.
sorry for interrupting you again, but you have to
Yes.
share your screen.
Ah, thank you. I don't know why it got unshared, but I must have clicked the button. Better?
All good now.
Thank you so much. It's getting late over there, so hopefully you're all still awake and I've not put you to sleep. If you're like me, you have your coffee. So I have my coffee mug ready here. All right. So using a native query is a matter of one way to do that is to add the @query annotation, and inside of your query annotation, you can specify the query to be used. So in this case, we're going to select all from book where the title is like title, and we're going to limit that to 2. And I'm going to call this find native books. So using a native query, if we switch back over to our controller and we swap out that to find native books instead, we can see once our application restarts, we'll see that the find by title method now is going to return us the book objects again, because of that's my return type that I defined over here. You can see we're returning a list of books and we're selecting all here, but you can see because we added a limit 2 that we're only going to get 2 back regardless of what our query is. So if we test that again, you can see we just get 2 back. All right, back to the slides. So there's additional query support. You can deal with joins if you have to, soft deletes, which is nice. You can do an @where annotation on your entity to handle soft delete support. You can do explicit queries using JPA. If you're using the JPA variety, using basically HQL here. You can do asynchronous queries. You can do reactive queries. Check out the link at the bottom of the screen there. All kinds of stuff that I really didn't even get a chance to mention, but you could check out the docs for more information on that. Pagination, very easy. Again, like everything else that we've looked at, to add pagination support, we just changed this to extend pageable repository. And if we come over to our controller, we can add another endpoint to get a page of books. So in this case, if we wanted to add support for pagination, it is really simple. So I've got an endpoint that accepts the page and the size of that page. So which page you want to fetch and how large do you want that page to be. We call the same find all method that we did above, but this time it receives a pageable object, which using pageable.from, we construct the pageable object, passing it the page and the size. And to test that, we can come over here and we have the book /0/2. So this will get us the first page with a size of 2 books in that page. So if we test that, you can see that our response here is a little different this time. We don't get an array of books back. We get actually an object. And within that object, your first key is called content. And within content, you have your array of items, right? So our books are within the content array of the returned object. And the reason that is because we're getting a page object back instead of an array. We're getting a page object. And within the page object, there are some meta properties down in the pageable key that tell us more things like whether there are more elements, what size we're working with, how many pages are available, the offset, things like this. All of these meta properties are returned to us so you can do your next call to retrieve your next page of objects. All right, let's talk about Graal native images, right? Everyone's probably heard of Graal native images, and I'll tell you why you should think about or consider using Graal native images. In this case, this is a very small test that I did about a year ago. And I took the same application and I used the just-in-time compiler and I compared it to the ahead of time compiled native image, right? So the just-in-time version, I did a 60-second load test on both. And this is a graph showing the performance of the JIT version of that test. You can see here, it's what you'd probably expect, some various spikes in the CPU. Your RAM is running at about 325 megs. Again, it's like a basic hello world application. So, you know, this is probably what you'd expect to see for a typical Java application. The JIT compiler is a little more performant than the regular JVM, but still probably what you're familiar with seeing. Now, the AOT version, as you can see here, I've blocked the axes, so you can't see the scale that we're working with here, but it looks quite different, right? You do see a few spikes in the CPU, which is the red. You see a few spikes, and you still see a very steady, consistent RAM utilization, memory utilization in the application. But when you consider the fact that this is spiking at 1% CPU and about 72, 75 megs of RAM for the exact same application, the exact same load test using the native image version, you can very easily and quickly see why using a native image is desirable and something that you would want to consider doing for your applications. And if I open up over here, it does take a little bit of time. So when you're working with native images, the trade-off is essentially it takes longer to compile and to create the native image. And but obviously you get that runtime performance, which is much better than using a non-native version of the application. So I'm not going to actually create a native image for you right now because it would probably be sitting here for the next 10 minutes watching it compile, but I have pre-created one ahead of time here. And you can see here, just to launch that, I just execute that as a binary, and very slow for some reason compared to normally. It's started up in 79 milliseconds. As I said, usually it's somewhere around 23, 30 milliseconds, but the startup time compared to, if we look at over here, my regular version, it's starting up in about almost 6 seconds. So comparing that to the native image version, much faster, much more performant. And as you could see with the graphs, the resource utilization much better. So to create a native image, Micronaut gives you out of the box a shell script and a Docker file. The Docker file will create the native image inside of the Docker container, Docker image, and then execute that at runtime. This is what the Docker file looks like. You can take a look at that. Since we're getting a little short on time, I won't do that now. Let's take a look finally at what it takes to connect up to a real database, right? So far, we've just been using H2 built in. So I want to show you, it really is just as easy to switch your application over to use a real database. So let me open up my database console here in IntelliJ. And as you can see, I have two tables in this schema right now, and neither one of them are called book. But if we wanted to use the Oracle DB in the cloud that I just showed you, that we can do that by my keyboard shortcut isn't working here. So if we come over here to build.gradle, the first thing we need to do is swap out the driver, right? So we were using, like I said, the H2 driver. In this case, I'm going to switch to the Oracle JDBC driver. And the next thing we're going to want to do is swap out our data source definition in the application.yaml. And I'll do that like so. I have an Oracle password environment variable set that will be picked up at runtime. And the final thing, well, two more things we need to do. The first of which is to come over here and swap out the type hint. So again, instead of telling it to use the H2 driver, we're going to use the Oracle driver. And finally, come back to our repository and tell it to use the Oracle dialect instead. So if I save that and we give it just a few seconds to restart the application, as soon as it's done restarting, and it's doing that now. Oh, our build failed. Why did our build fail? Oh, it cannot find okay, so I must have not set the environment variable. I'll do that now. And we'll run it again and give that just a second. And as soon as that starts up, because we're using the create drop schema generate option, it's going to create my table for me, and we'll see that in just a second. So we're at about 42 minutes here. Thankfully, that's, I think, just about all of my slides. Yep. But I've really just scratched the surface as to what you could do with Micronaut Data. It's really, I hate to repeat myself here, but it's very powerful. It's very flexible. It's easy to learn. It's intuitive. It's which basically means it's very easy to kind of assume what you might have to do something that you're not familiar with. I encourage you to dig in yourself. Go to launch.micronaut.io. Create a new project, check out the docs. The guide link is at the bottom of the page here. And if you want to contact me, my blog is recursive.codes. I am Recursive Codes on Twitter. I'm on YouTube. Connect with me on LinkedIn if you're interested. Check out the Oracle Developers blog. If you have any questions, you can email me directly, todd.sharp@oracle.com, or message me on Twitter. My DMs are open. I thank you again so much for having me here at JCON. I really wish I could be there in person and share a beer with all of you, but perhaps next year we'll get that. And thanks again. Let's take a look at the questions. Dialect has to be on each repository. It does have to be on each repository. I imagine you could probably create a base class and define it on that, and then extend that base class. But now consider the fact that a lot of times when you're looking at microservices and you're dealing with microservices, you're not going to have a ton of repositories probably in every application. You might just have one or two repositories in an application in a microservice type environment. Excuse me. Now, when working with the JPA variety of Micronaut Data, you do not have to specify the dialect. You do that in your configuration file like you would normally do with Hibernate. So it's really only necessary when using the JDBC variety. What if projection should include title and pages? Alex, I think I've answered that already. You would use a DTO, data transfer object, and you could include as many properties or as few properties as you need to. I hope that's my connection. Yeah, I'm sorry about that. Again, I'm never going to use those wireless pods again. What is the biggest challenges you encounter when using Micronaut Data? How does it work with transactions? The biggest challenges, to be honest with you, I have used it in a few applications. I guess I've not really encountered any big challenges. And the reason I haven't is because, again, I've kept things very simple. I've used it for microservices, which are straightforward, create an object, get an object, delete an object, update an object. I've not tried to do a full-blown or even monolithic type application with it, where you're dealing with a very large object graph, you're dealing with complex associations, relationships, things like that. So I can't speak to that. I don't know that I would use it for that. You know, there are other tools, Grails, for example, which is really powerful at that kind of thing. Maybe I would. I can't say for sure. Transactions, that is a great question, and I'm afraid I'm drawing a blank on how it works with transactions. I know when you use the JPA variety, transactions work just as they would in Hibernate, but I can't speak as to how it. I would imagine that each service is wrapped in a transaction using JDBC, but I can't say for sure. Sasha asks, it's able to configure dialect in the annotations outside the class and support multiple databases. Check the docs on that, Sasha. Check the docs on that. I think there is multiple database support. In fact, if you look at the fact that I have a data source here defined with the name default, the fact that it's not a top level data source tells me that there is support for multiple data sources. But again, I don't have that memorized at right now. So check the docs on that. Do you know when Micronaut Data may support NoSQL? I know it's on the roadmap. I know it's something that the team wants to do. I don't know how extensive we would look at for that. Obviously, Mongo would probably be on the list. I think GraphQL might be on the list eventually. I think the intention is to kind of be similar to GORM and support the same types of things that GORM supports. But stay tuned for more information on that. Bella Submarinian asks, what is the difference between Micronaut JDBC and Micronaut JPA? JPA uses, basically it's Hibernate. You know, it's the Hibernate that you're familiar with, and it adheres to the JPA spec and so on and so forth. JDBC is just SQL. It just constructs raw SQL queries behind the scenes and executes them at runtime, right? So there's no Hibernate in between. There's no object relational mapping going on. It's just, here's an entity, create a query out of that entity and execute that SQL query. Thank you all again for having me, and cheers. Thank you very much. Take care.